Section 2.4 is reviewing operations with complex numbers. As a reminder, complex numbers include real and imaginary numbers, so they're in a very inclusive group of numbers. Standard form for a complex number is a plus bi, where a is the real component and b is the imaginary component. I is equal to the square root of -1. That's why it's called the imaginary unit. And if you square both sides, I squared equals -1, which does help us to simplify many complex expressions. A plus bi and a minus bi are complex conjugate, where the real component is the same and the imaginary component is opposites. Okay, so for example one, we're just going to review the basic operations using complex numbers. So for the first one, part A, 5 plus 4i plus 7 minus I. I'm just combining the like terms and writing my answer in standard form. You could probably do this all in one step because I'm really just doing this. If I combine the real components, I have 5 plus 7 is 12. 4i minus I is positive 3i. So 12 plus 3i is my answer in standard form. The next one, for part B, it's 5 plus I minus 2 minus I plus 4 minus 2i. I'm going to distribute the negative just to get my signs straight. Minus positive I plus 4 minus 2i. And then again, I'm just combining the real and the imaginary components. So 5 minus 2 is 3. 3 plus 4 is 7. I plus I minus 2i. Was that 2i minus 2i? That actually cancels out. So I'm just going to write 7, and it has only a real component. If you wrote 7 plus 0i, that's also fine. Okay, for part C, I'm doing 2i times 5i. 2i times 5i is 10i to the second power. And you don't ever want to leave an exponent on your I, because if it's the exponent is greater than 1, it can always be simplified. Because I squared is equal to -1. We were reminded of that at the beginning. So I squared equals -1, which means this is really 10 times -1, which is -10. And again, don't leave an exponent on your I. If there's an exponent on your I, it can always be simplified, a non-1 exponent. Okay, D, I'm going to multiply 2 minus 5i times 3 plus 4i, and I'm going to distribute it out in whichever manner is most comfortable for you. I have 6 plus 8i minus 15i minus 20i to the second power. I'm going to simplify this, so 6 minus 7i minus 20. Okay, now I have an I squared here, and I know I don't want to leave an I squared there. So I'm going to remember that I squared equals -1. Okay, and if you in your head you multiply by -1, that would be fine. If you multiplied it in your head, then you turn this into a plus 20. So this is going to be 26 minus 7i in standard form because I put the real component first and the imaginary component second. Okay, moving on to E. E is 5 plus 2i to the second power. Just keep in mind this is actually 5 plus 2i times 5 plus 2i. You don't need to write them out 2 times, but you need to remember that so that when you multiply it, you're treating it like that. This will be 25 plus 10i plus 10i is 20i plus 4i to the second power. Okay, so 25 plus 20i. Okay, I squared is -1. So if I do 4 times -1, I get -4, which will make this 21 plus 20i. And it's this complex number in standard form, so I've probably simplified as much as I can. Okay, for the last 3, we're actually going to be dividing. Okay, so if you look at F, it looks like an okay fraction. The main issue is that there is an I in the denominator. And when we are simplifying fractions, we don't leave radicals in the denominator, and I is actually a radical, so we don't want to leave it there. Okay, there's more than one way to do this, and we come out with equivalent answers regardless of what choice you make. Okay, I want the I to cancel. I'm going to multiply the denominator by I because I'll get I squared, and I know that I can turn I squared into -1. If I multiply the denominator, I have to also multiply the numerator. So what am I going to get? I'm going to get 4i at the numerator. I'm going to get 3i to the second power. Okay, and again, because I know that I squared equals -1, I have, in the denominator, I have 3 times -1, which is -3. So I have -4/3 I. Okay, and this complex number happens to only have an imaginary component, which is fine. And if you had done it differently, some people like to multiply by -I, some people multiply by -3I. And once we simplified out our fraction, we would have had an equivalent fraction. Okay, now part G has a similar problem as F. It's 1 over 3 plus I. I cannot leave the I in the bottom. Okay, now the dilemma with this one is if I multiply the denominator by I, I'm going to end up with 3I plus I squared. So I'm still going to have an I in the denominator, which isn't going to help my situation at all. Okay, so if I have two terms or a real and imaginary component in my denominator, I'm actually going to multiply by the complex conjugate of the denominator. So this is 3 plus I. So I'm going to multiply by 3 minus I. If I do it to the denominator, I have to also do it to the numerator. Because now in the denominator I have this nice difference of squares, it will end up turning out to be having only a real component in the denominator. But let me distribute this out. So in the numerator, I have 3 minus I. And the denominator, I have 9 minus I squared. Okay, and some of you can do that in your head. 3 minus I squared is -1. So 9 minus -1 is 10. Okay, this is a nice answer, but it's not actually in standard form yet. And on WebAssign, they will actually want this in standard form. So I'm going to split this into 3 over 10 minus I over 10, or minus 1/10 I. So now I have the real component first and the imaginary component second. So that's standard form for a complex number. Okay, last one like this is going to be H, and it has that same issue. There's an I in the denominator. So I'm going to have to find a way to get rid of it. Because it has a real and an imaginary component, I'm going to multiply by the complex conjugate in order to get the denominator to look nicer. Since I have 4 minus 5i, I'm going to keep the real component the same, and I'm going to do the opposite for the imaginary. So 4 plus 5i. And again, we're trying to make this difference of squares, which is why it always has kind of that pattern. Okay, this one is going to be a little more work to multiply though. Okay, so I'm just going to go ahead and multiply it out the long way. So in my numerator, 8 plus 10i plus 12i plus 15i squared. And in the denominator, at least that's a difference of squares. So 16 minus 25i squared. Okay, I'm going to keep moving with this until I can make it look a little nicer. So 8 plus 22i. I squared is -1, so 15 times -1 will make this -15. For the denominator, I have 16 minus 25i squared. I squared is -1, so -25 times -1 will change it to +25. Let's see, I'm almost there. In the numerator, I have -7 plus 22i. My denominator adds up to 41. And then I'm just going to split this into standard form just for the sake of the niceness of the answer. So the real component is -7 over 41. And then the imaginary component is 22 over 41. And that, even though it doesn't look better, it's a nicer answer than the original. Okay, for example 2, I'm going to be solving some quadratics that have complex answers. Just to kind of remind you what are some options when you're solving and how to express your answers. Okay, so for the A, it says x squared plus 9 equals 0. If it were a -9, I would probably factor it, but it's not. So I'm going to solve using square root. I'm going to move the 9 to the opposite side. Okay, and then I'm going to imagine I'm square rooting. Because this is a quadratic, I'm going to get two answers, a positive and a negative. So I'm going to get plus and minus. The square root of 9 is 3. The square root of -9 is imaginary 3. So I'm going to get plus or minus 3i. Okay, I got both of my answers, which I was expecting two answers because it's okay. I changed b a little bit, but b is 2x to the second minus 7 equals -17. And I'm going to solve it very similarly to a. I'm going to use square root on it. So I'm going to go ahead and add the 7 over. 2x to the second equals negative 10. If I divide both sides by 2, I get x to the second equals negative 5. If I'm square rooting, I'm going to get two answers. I get x equals plus or minus. Now, square root 5 is irrational, but it's also imaginary. So I'm going to say I have plus or minus imaginary square root 5. You don't want to leave the negative inside the radical, but you can, of course, refer to it as an imaginary square root 5. Okay, for part C, I have x squared minus 4x plus 5. If I could factor it, I absolutely would, but if I want to multiply to get 5, it would be 5 times 1, and that does not add up to negative 4. But because my b value is even and my x squared has a coefficient of 1, I think I'm actually going to complete this square. You could also do quadratic formula if you would like, but there might be some simplifying involved, because if you can complete the square, normally you need to, but quadratic formula will require extra simplification. So I'm going to move the 5 to the other side. Okay, then I'm going to go ahead and complete the square. I think most of you learned to divide b by 2, which is negative 2. Negative 2 squared is positive 4. To add it to the left, add it to the right. Okay, this should be a perfect square now. Equals negative 1. Okay, now I can solve using square root. See, x minus 2 equals, and it was quadratic, so I should get a positive negative. Now the square root of negative 1, square root of 1 is 1, but it's a square root of negative 1, so this is going to be plus or minus I, or plus or minus 1i. Okay, I'm just going to move the 2 to the other side. So I get 2 plus or minus I. And that is two answers because one of them is 2 plus I and one is 2 minus I, and that's in standard form. Okay, one more example. D says 3x to the second minus 2x plus 4. Again, if I could factor it, I probably would, because for me that's the fastest way. You could complete the square, but with the coefficient of, with a value of 3, and seeing that b is not divisible by 3, it might be a lot of work, so I'm going to go ahead and quadratic formula this. So I'm going to get x equals negative b, and b is negative 2, so this is positive 2 plus or minus. B squared is 4 minus 4ac all over 2a, and now I'm just going to simplify it. So 2 plus or minus 4 minus 48 over 6. Let's keep going. 2 plus or minus the square root of negative 44 over 6. I can see I'm going to have an imaginary component on this. Okay, now I do want to simplify the radical. I know I can definitely take out an I. Additionally, I could simplify the 44 depending on how you learned it. You might have learned to make this 4 times 11, which makes it 2 root 11. You might have made a little factor tree and looked for repeats. Your method is up to you, but how I would write this is 2 plus or minus. It's going to be 2 square root 11, but it's imaginary. So you write 2i square root 11, and then the whole thing's over 6. Okay, now if I can simplify this a little more, I absolutely will, and I can. And I want to put this in standard form. Okay, so if I look at this, the first one is 2 over 6. I can simplify 2 over 6. That's going to be 1/3. Okay, plus or minus. Now for the imaginary component, I have 2i over 6. I can divide both of those by 2 or take out a factor of 2. So I will have I root 11 over 3. This is my final answer. It is two answers. They are both in standard form for a complex number.